All right, so question 15. Let's take a look here. This is a velocity versus time graph, and that tells us something quite a bit different about what the object's doing. So we're moving forward, and then we're slowing down, and we stop for a second, and then we start moving backwards and speeding up, which is exactly what happens here in choice A. Again, this isn't a where you are graph. This is a how fast are you going graph. So I'm really fast here. And I'm really fast here. And here I'm stopped. So I'm going fast to slow, slow to fast, and I'm traveling forwards here, stopping, and then going backwards and fast here. Now here, this shopper is pushing a cart, and we want a free body diagram. So let's see if we can draw it. So we've got the weight, we've got the normal force, we've got the friction force, and we're pushing downwards like that. And what that means is choice D is, in fact, what this free body diagram looks like. And then for number 17, what is the total combined force of this cart equal to? Well, let's see. Well, we're moving at constant velocity, which means the force is balance. And also vertically, since the cart is not moving vertically up and down, we also balance in that direction. So that means that we are not non-zero here. That's not right, and that's not right. The cart is moving, so the only choice we're left with is B, which says 0 in the horizontal direction since the cart is moving horizontally at constant velocity, 0 vertically because there's no movement in that direction. So an object is placed on a planet with the acceleration due to gravity is half that of Earth. What is its weight on this new planet? Well, we know that weight equals mg for any object. So now that g becomes half its value on Earth, we're going to get half the weight here. So F1 is a force exerted by Earth on a baseball, and F2 is the baseball exerted on the Earth. Whenever you have these third law situations, remember they are equal because of Newton's third law, which says that if A pushes B, B pushes A with an equal and opposite force. And finally, we want to know the force of friction, if this is the mass and this is the coefficient. Coefficient of friction. People keep reading this word and they ignore what comes before it. Read this whole thing. So friction is fun. That's going to be, friction is mu times the normal force, which is 0.2. Now let's see. We're getting a situation where we've got a normal force, a pushing force, a friction force, and then the weight. Now here's the thing, we don't care what the pushing force is, but we do know the normal balances the weight, so that's going to be mg, which is going to be 2 times 10. So we're getting 0.2 times 20. So I'm getting a 4 Newton force for my friction force. So that's it for the multiple choice, and in the next couple videos, I'll take a look at the free response.